Hello students, welcome to the second lecture on the lecture series on work and time. Okay, so in this lecture what we will be covering is some exercise problems as we have previously learned all the concepts, basic concepts and the types of problems that are being asked in various competitive exams. So we will be exploring numerous exercise problems in this lecture. So let's proceed with it. So this is the second lecture and we will be covering exercise problems. Okay. So let's see problem number 1. So if John can paint a fence in 5 hours, then calculate his work rate in terms of fences per hour. Okay. So John can paint a fence so he can paint actually one fence in 5 hours. So calculate his work rate in terms of fence per hour. Okay. So let's see. So define the variables. So let R be the work rate of John in fence per hour. Okay. So using the formula for work rate is equal to work done by time, right? So work done by time is equal to what? 1 fence by 5 hour is equal to 1 by 5 fences per hour. So the answer will be 1 by 5 fences per hour. Okay. So if John can paint a fence in 5 hours, the work rate in terms of fences per hour will be 1 by 5 fences per hour. Okay. So let's see problem number 2. So if Alice can complete a puzzle in 3 hours, calculate her work rate in terms of puzzles per hour. Okay. So Alice can complete a puzzle in 3 hours. Okay. Alice takes 3 hours to complete one puzzle. Then calculate the work rate in terms of puzzles per hour. Okay. So given that, defining the variables R be the Alice's work rate in puzzles per hour. Okay. Then using the formula for work rate, that is equal to R is equal to 1 by 3 puzzles per hour. That is equal to number of puzzles by number of hours. Okay, so 1 by 3 puzzles per hour. So Alice's work rate is 1 by 3 puzzles per hour if we are given the work rate in puzzles per hour. Okay, so if Alice can complete a puzzle in 3 hours, so her work rate in terms of puzzles per hour will be 1 by 3 puzzles per hour. Okay. So let's see problem number 3. So David can build a model in 6 hours. So David can actually build a model in 6 hours. For how much models? One model. Right. As this is written here, a model. So if he works at half his normal speed, how long will it take him to build the same model? Let's see. So defining the variables, let t be the time it takes when working at half the speed. Okay, so set up the equation based on work rate. So R1 into 6 is equal to what? R2 into t. So solving for t is equal to what? 6 by 2 is equal to 3 hours. So it will take David 3 hours to build the model at half his normal speed. Not half, it will be at twice his normal speed. Okay, because he can build a model in 6 hours. So if he works at twice his normal speed, then it will take 3 hours to him to complete the model. So if he takes half of his normal speed, how much will it take? So that same work, so work into time is equal to what? 6 into 1 is equal to x into 1. So it took half of, sorry. So if his speed is half, that is 3, not 3, the work is half completed in that time, that is x into 1 by 2. So this implies that x is equal to what? 12 hours. If his speed is half, then he will take 12 hours to complete the same model. Okay. So let's see problem number 4. So Mary can complete a book in 12 hours. Okay. So how much time does Mary take to complete a book? So if she works for 2 hours and then takes a break for 1 hour, how long will it take her to complete the whole book? Okay. Here you can see that Mary can complete a book in 12 hours. So Mary takes 12 hours to complete a book. So if she works for 2 hours, then she takes a break for 1 hour. So let's see it fundamentally. Okay, so these are a little bit tricky questions. So there is a slight different approach that you need to make here. Okay, so if Mary can complete a book in 12 hours, okay, so how many 2-hour slots does she need? So 12 by 2 is equal to 6. So 6 number of slots of 2 hours. Okay, so since what, if she works for 2 hours and then takes a break for 1 hour, okay, so for each 2 hour there exists a break of 0.5 1 hour, right? So for each 2 hour she will take a break for 1 hour. So basically for 6 slots, how much time she will take as rest? So for each 2 hour slot she will take 1 hour as rest. Okay, so for each slot, so 6 hours of rest, right? This is what you must have been thinking. So you will say that total number of hours she will need is 12 plus 6 is equal to 18, but this will be wrong. Okay, so how wrong? How this thing is wrong? Okay, up to this everything is correct as we have followed the all the data given in the question, right? So what we are missing here is after doing the 6th slot, the work is finished. So the rest time won't be considered. So if 1 hour of rest time is not considered, then there are 5 hours of rest, right? So if she takes 5 hours of rest and 12, that is 6 slot of 2 hours, that is 12 hours of work. Total how many work hours? That is 17 hours of time, okay, to complete the book. So the answer will be 17 hours. So she will take 17 hours to complete the book. So Mary completed how many? One book in 12 hours. Okay, this is Mary's speed. So what we did was we told Mary that she can take 1 hour break for every 2 hours of work. So how long will she take to complete the book? So what we do next is we divide the 12-hour slot in 2-hour slots. Okay, so we got 6 slots, and for after completion of each slot, she will take rest of 1 hour. Okay, so for each 2 hour there exists a break of what, 1 hour. So since there are 6 slots, we must think that she will take 6 hours of rest. But here is the tricky part. Okay, after doing the 6th slot, she will take the rest, but after doing the 6th slot there are 12 hours of working is completed, so the job is done here. Okay, so the rest period won't be considered. Okay, so only 5 hours of rest, that is the rest after the first slot, then after the second slot, then after the third, then after the fourth, then after the fifth, after the sixth it won't be considered, right? So up to 5, so 5 hours of rest, right? So 12 hours of work and 5 hours of rest, that is equal to 17 hours of what? 17 hours of completion or time to complete that book. So 17 hours will be the correct answer. So A can complete a job in 9 days. Okay, given that A can actually complete a job in 9 days and B can complete the same job in 12 days. So how long will it take if A and B work together to complete the job? So this kind of problem we have already discussed. This is a combined work problem, right? Work problem. So let's get a rough sketch of what we are gonna do. Okay, we'll calculate the work rate of A and work rate of B individually. Okay, so then we'll calculate what their work rate, B's work rate, and then what we do is calculate their combined work rate. So combined work rate is how it is calculated: 1 by x plus 1 by y. We have already discussed in the previous lectures, right? So it will be what, 1 by 9 plus 1 by 12 is equal to what, 12. So this is 4. So this won't be 12. This will be what? This will be 36. So this will be 4 plus 3. is equal to 7 by 36. Okay, this will be the combined work rate. So combined work rate is equal to A's work rate plus B's work rate, that is equal to 1 by 9 plus 1 by 12. That is actually equal to what? So it is actually equal to 7 by 36. So find the time required to complete the job together. So time is equal to what? 1 by combined work rate. So time is equal to 1 by 7 by 36. It is equal to 36 by 7. Okay, dividing 36 by 7, what we arrive at is 5.14. So for A and B to complete the job together, they need 5.14 days. Okay, so let's review the question again. If A can complete the job in 9 days only and B can complete the same job in 12 days, so they both have different work speed or work rate. Okay, so how long will it take if A and B work together to complete the job? So first what we do is we figured out the A's work rate and B's work rate individually. Then we summed them up to find the combined work rate, right? So we summed them up and we arrived at 7 by 36. So then what we do is we found the time required to complete the job together. Okay, so time is equal to what? 1 by work rate or 1 by combined work rate in this case. Okay, so 1 by combined work rate was 1 by 7 by 36. So taking the reciprocal of 7 by 36, we arrive at 36 by 7. That is equal to nothing but 5.14. Okay, so this is the correct answer. So it will take 5.14 days for A and B to actually complete the job together. So problem 6. Okay, if A can paint a wall in 6 hours, okay, A paints a wall in 6 hours and B can paint the same wall in 9 hours. So if they start painting together but B leaves after 2 hours, how long will it take A to finish the painting of the wall? Okay, so let's see. A can paint the wall in 6 hours. Only 6 hours it takes for A to paint that wall. And B can paint that same wall in 9 hours, right? So this seems to be a similar kind of problem, similar kind of combined work problem. So if they start painting together, but B leaves after 2 hours, okay, in this question we have a tricky part here. That is B leaves after 2 hours, okay. So can you guess what we need to do? Okay, we will see. We'll have to break the problem in 2 parts, okay. How their work rate is up to 2 hours and after that what it will become. Okay, that is how we'll break the problem and solve it. Okay, and we'll get the correct answer. Okay, so there is no need to be scared in this kind of problem. Okay, so you just go through it smoothly and try to figure out how to break the word problem into smaller word problems so that you can convert it to an algebraic problem and then solve it for x and then you are there with the answer. So how long will it take A to finish painting the wall? Okay, so let's calculate the combined work rate. So in order to figure out what is the combined work rate, what we have to calculate first is we have to calculate the work rate of A, that is equal to 1 by 6. Okay, and work rate of B is equal to what? 1 by 9. And combined work rate is equal to 1 by 6 plus 1 by 9. That is equal to what? So 36. So it will be 6 plus 4 is equal to 10 by 36. Okay, since the combined work rate is 10 by 36, let's figure out how much work is actually done in 2 hours. Okay, so this much of work is done in an hour. Okay, so in 2 hours per hour. Okay, so in 2 hours work done is equal to 10 by 36 into 2, right? That is equal to 20 by 36. That is nothing but what? 10 by 18, right? So 10 by 18 is nothing but 5 by 9. So 5 by 9 of the work is done in 2 hours. Okay, so how much is the remaining work? So remaining work is 1 minus 5 by 9. That will be equal to what? 9. So 9 minus 5 is equal to 4 by 9 of the work. Total work is remaining now. Okay, and we know how much it takes for A to finish 4 by 9 of that work. How can we know? So we can use the formula, but time needed is equal to age speed, remaining time, that is 4 by remaining work, that is 4 by 9, and age work speed, okay, or work rate, that is 1 by 6. So 4 into 6 by 9, 24 by 9 is equal to what? So this is 3 and this is 6. No, this is 8. So 8 by 3 hour. Okay. This is how much it will take for A to finish the remaining part, that is 4 by 9th of that wall to paint. So what we did first was we find out individual work rate of A and B, that is 1 by 6 and 1 by 9, that is 1 by 9 wall per hour and 1 by 6 wall per hour respectively for B and A. Okay. So let's see step 2. So what we needed at that time was we needed the combined work rate. So what we did, we added the A's work rate and B's work rate and we got 1 by 6 plus 1 by 9. That is nothing but 5 by 18. Okay. So the combined rate was this much. Okay. 10 by 36, that is equal to what? 5 by 18. Okay. So in 2 hours, the fraction of work done is equal to what? 2 into 5 by 18. Okay. So that is equal to 5 by 9 or 10 by 18. That is actually equal to 5 by 9. Okay. So what we do next is we find out that the remaining work, okay, after leaving of B, what is A left with? How much of work is needed to be done in the wall? Okay. So remaining work is equal to 1 minus fraction of work done, that is 1 minus 5 by 9 is equal to 4 by 9. So time is equal to remaining work by A's work rate, that is 4 by 9 whole by 1 by 6. So it will take A approximately 2.66 hours to finish the painting. Okay. So this is equal to nothing but 24 by 9 is equal to what? 8 by 3. This much hours, that is 2.66 hours. Let's see problem number 7. If A can build a wall in 8 days, okay, what does it do? A builds a wall in 8 days and B can build it in 12 days. Okay, B can build a wall in 12 days and C can build it in 24 days. Okay, they start working together. So A, B, C, there are 3 people involved here. Till now we have seen work problems with 2 people involved, but in this case there are 3 people involved. Okay, A, B and C, and they all have different work speed or work rate. Okay, A have a work rate of 1 by 8, B have a work rate of 1 by 12 and C have a work rate of 1 by 24. So they start working together. Okay, initially what they did was they started working together, but C left them after 2 days. Okay, so what did C do? C left after 2 days. So how long will it take for A and B to complete the wall? Okay, so what we do, we start calculating the combined work rate. So it will be what? 24. 3 plus 2 plus 1. So this is 24. So 5 plus 1 is equal to 6. So 1 by 4. So 1 by 4 is the work rate, combined work rate. Okay, in 2 days. So this is what? 1 per day. Right. So in 2 days, the fraction of work done will be what? 2 into 1 by 4 is equal to 2 by 4 is equal to 1 by 2. Okay. So half of the wall is actually built. Okay. So now what she does is she left. Okay. So leaves right now. So right now the fraction of work remaining is equal to the fraction of work remaining equal to 0.5. Okay. So 0.5 is the amount of work remaining. Okay. So right now after C left, what is the combined work rate? So combined work rate will be 1 by 8 plus 1 by 12, right? So this will be 24. So 3 plus 2 is equal to what? Is equal to 5 by 24. Okay, 5 by 24 is what? The combined work rate. So how to calculate the time needed? Extra time needed is equal to extra time needed is equal to what? So the amount of work remaining, that is 0.5, so 1 by 2 whole by A and B's combined work rate, that is 5 by 24. So this is nothing but equal to what? 24 by 10. So 2.4 days. Okay, 2.4 days it will take for A and B. Okay, extra 2.4 days to complete that work. So let's see a step-by-step solution. So first what we do is we found out the individual work rate. So A's work rate is 1 by 8, so 1 wall per 8 days. And B's work rate is 1 wall per 12 days. Okay, and C's work is 1 wall per 24 days. Okay, so we have written here the 3 work rate, that is work rate of A, work rate of B, and work rate of C as 1 by 8, 1 by 12, and 1 by 24 wall per days respectively for A, B, and C. So in step 2, what we do is we calculate their combined work rate. Okay, so combined work rate will be what? A's work rate plus B's work rate plus C's work rate. So combined work rate is nothing but 1 by 8 plus 1 by 12 plus 1 by 24 is equal to 1 by 4. Okay, so calculating the fraction of work done in first 2 days. Okay, so what do they do, or how much work they do, or how much of the work is made in 2 days. So fraction of work done is equal to what? Combined work rate into amount of time, that is 1 by 2 into 2, that is equal to, this is 1 by 4 into 2, right? Is equal to 1 by 2. So 1 by 2 is the answer. That is the fraction of work done. That is half of the wall is made or built. So step 4 is find the remaining work and the time required for A and B to complete it. So remaining work is equal to 1 minus fraction of work done is equal to 1 minus 1 by 2 is equal to 1 by 2. Okay. So work done by A and B together in 1 day after C leaves. So 1 by 8 plus 1 by 12 is equal to 3 by 24 plus 2 by 24, right? So this is nothing but 5 by 24 of that wall, right? So work done by A and B together, that is the combined work rate of A and B will be 3 by 24 plus 2 by 24, that is 5 by 24 of that wall. So time taken by A and B to build the remaining half of the wall is equal to what? Time is equal to work by rate. So time is equal to what? Work remaining, that is the remaining work, that is 1 by 2, and the combined work rate of A and B, because only C left, right? Not B or not A. So only C left. So that's why we calculated the combined work rate of A and B. So it became 5 by 24. So solving it, 24 by 10, that is equal to 2.4. So to divide these fractions, multiply the fractions by the reciprocal of the second. Okay. So what we are left with is 12 by 5, or is equal to time is equal to 2 into 2 by 5 days, that is 2 days and 9.6 hours, that is 2.4 days. Okay. So since 2 by 5 of 24 hours is 9.6 hours. Okay, this is time is equal to 2 whole and 2 by 5 days. Okay. So this will be the correct answer. Or 2.4 days, any of one is correct. Okay. So let's see problem number 8. So A can complete a project in 10 days and B can complete the same project in 15 days and C can complete the project in 30 days. Okay. So they start working together, but after 4 days, C leaves. Okay. How long will it take for A and B to complete the project? Okay. So as at first glance, you can guess that this problem is actually similar to problem 7. Actually, indeed, it is very, very similar to problem number 7. The only thing changed here is they tried to build a wall, and here it is about a project. Okay. So let's approach it with a similar pattern. Okay. So what we need to do is we need to calculate for up to 4 days their combined workforce or combined work, that is A, B and C. Okay. So their individual work rate will be A's work rate is equal to what? 1 by 10. In a similar way, B's work rate is equal to what? 1 by 15, right? and C's work rate is equal to 1 by 30. So their combined work rate is equal to what? 1 by 10 plus 1 by 15 plus 1 by 30, right? So this is equal to what? 30. So 3 plus 2 plus 1. So this is equal to what? 5 plus 1 is equal to 6 by 30 is equal to 1 by 5. So 1 by 5 is their combined work rate. This much amount of project per day. Okay. So what they do is they continue the work for 4 days. So in 4 days, amount of or fraction of work done is equal to what? 4 into 1 by 5, because in 1 day they complete 1 by 5th of that project. Okay, so this is equal to 4 by 5. So 4 by 5 of the work is now done. Now what happens is C leaves. Okay, C leaves the team. Okay, so amount of work remaining, amount, or you can also say fraction of work remaining is equal to what? 1 minus 4 by 5. This is equal to 1 by 5. Okay, right now what we need to do is we need to calculate the combined workforce of A and B. So combined work rate of A and B is 1 by 10 plus 1 by 15, right? So this will be equal to 30, 1 by 30. So this will be 3 plus 2 is equal to 5 by 30 is equal to 1 by 6. Okay, so right now the extra time needed for A and B to finish project is what? The remaining amount of work, that is work by time, work by work rate. Okay, so 1 by 5 whole by 1 by 6, that is equal to 6 by 5. Okay, this much amount of days they will need to complete the project. So let's see the step-by-step solution. So in step 1, what we do is we found the individual work rate. Okay, so we found the individual work rate, that is A work rate is equal to 1 by 10, and then we found out B's work rate is 1 by 15 and C's work rate is 1 by 30. So combined work rate will be what? 1 by 10 plus 1 by 15 plus 1 by 30, right? So calculating the fraction of work done in the first 4 days. Okay, so fraction of work done will be what? Combined work rate into 4. So finding the remaining work and the combined work rate of A and B. Okay, so the fraction of work done is equal to 1 by 5 into 4 is equal to 4 by 5, right? So the remaining work is equal to 1 minus 4 by 5 is equal to what? 1 by 5. So fraction of work done is equal to what? 1 by 5. This much amount of work is remaining. So combined work rate of A and B is equal to 1 by 10 plus 1 by 15. That became what? 1 by 6. Okay. So 1 by 6 is their work combined work rate. Okay. This is 1 by. So time is equal to total remaining work by combined work rate of A and B. So it will take A and B approximately 4 days to complete the project. Okay, so this is wrong here. So this will be what? 1 by 5 whole by 1 by 6, right? So this will be 6 by 5 days. 6 by 5 days is the amount of time they will take to complete the project. This will be 6 by 5 days. Okay, so a whole day and some more day. Okay, so that's enough for today. Thank you.